Okay, this is continuation homework problem review section 1-4. And we start out by just being asked to draw figures. So I did a few of these. First one asked for an obtuse angle RST. And if we remember from the first lesson, obtuse meant that you're greater than 90 degrees but less than 180 degrees. So I've depicted that here. And because this is angle RST, S has to be the vertex, and RT can be on either side. For number 16, an acute angle GHJ. Again, H is the vertex because it's the middle term, and an acute angle means you're less than 90 degrees. And lastly, number 17, a straight angle, KLM. So straight angle means 180 degrees, L being the vertex is in the middle. Let's look at the next set of problems. So first of all, for 22, I've kind of copied the figure here depicting what they show in the book. So you have these two angles, one being DBC, the other one being CBA, and they are adjacent to one another. And you're given the information that angle ABD is equal to 79 degrees. And it wants to know what is angle ABC and what is angle DBC. And they give you the formulas for the angles. So these are not the lengths of the lines. These are actually formulas for the angles around those vertices B. So the first thing we have to do is solve for X. Because if we have X, then we can just plug that into the formula and determine what those angles are. So we know that this total angle, ABD, is equal to the component angles, ABC and CBD. So ABD is equal to angle ABC plus angle CBD. Plugging in the values that they gave us, 79 degrees is equal to 8x minus 3 plus 5x plus 4. Simplifying, by bringing the x terms together and the numeric terms together, I get 79 is equal to 13x plus 1. Subtracting 1 from each side, 78 is equal to 13x, or x is equal to 6. I can then plug in that value for 6 into the expressions. So angle ABC is 8x minus 3. It's equal to 8 times 6 minus 3, which is 45. And I have angle DBC, 5x plus 4, which is equal to 34 degrees, and I can check my result because I know that the angle ABD, which is 79, has to equal to the sum of those two angles. 45 plus 34 is indeed 79, so that does work. Now going over to our next problem, 23, we have the angle RQT is a straight angle, straight line, and they want to know what RQS and TRS are. And again, they give us the formulas for what the angles are. Again, not the length of the line, but the angles. So knowing it's straight angle tells it's 180 degrees, and the two component angles, SQR and SQT, have to sum up to 180. So I plug in the formulas that they gave me. 180 degrees equals 2x plus 4 plus 6x plus 20. Again, combining all the like terms, I get 180 equals 8x plus 24. Subtracting 24 from each side and then dividing by 8, I get 19.5 is equal to x. So I can now put the x value back into the expressions for RQS and TRS. In the first case, I get 2 times 19.5 plus 4 gives me 43 degrees. And then for angle TRS, I get 6 times 19.5 plus 20 is 137 degrees. And again, I can check that result because the sum of those two should equal 180 degrees, which it does. All right, so now we'll wrap up by going to questions 29 and 30. So for 29, and this figure is the same one that's used for both of them. You have an angle AOB, BOC, and COD all adjacent to one another. So they ask you to solve for x and the measured angles. So in the first case, they give you AOB is 4x minus 2. It's that one. BOC is 5x plus 10, that term. And COD is 2x plus 14. So they give you each of the three components. But they also give you one more fact in the depiction. Those little symbols there mean that that angle, COD, and that angle, AOB, are congruent, which means they are equal. So the angles are equal, AOB equaling COD. So I can now solve for x by saying that the terms they gave me, the expressions for those two angles are equal. 4x minus 2 is equal to 2x plus 14. Combining the like terms again by subtracting 2x and adding 2 to each side, I get 2x equals 16, or x is 8. I can then plug that back in to the formula, and I have 4x minus 2 becomes 30 degrees for AOB. For BOC, I get 5x plus 10, which is 50. COD is 2x plus 14, which is 30. And because it's congruent to AOB, it's the same number. And then the total angle is the sum of those 30 plus 50 plus 30, it's 110. Last question. So here we have the same figure. Now they give us AOB is 28 degrees. It's that angle right there. They tell us that BOC is 2x or 3x minus 2. That's the middle one. And that the total angle from AOD, the whole thing, is 6x. And they also again have that AOB is congruent to COD, so that tells us that both of those angles are 28 degrees. So now we know the total angle, AOD, that's got to be equal to the sum of those three components, right? So your total angle is that angle plus that angle plus that angle. 6x equals 28 degrees plus 3x minus 2 plus the other 28, because that's the congruent angle. So 6x is equal to 3x plus 54 when I just gathered the like terms together. Subtracting 3x from each side, I get 3x equals 54, or x is 18. I can then plug that in. Okay, so AOB I was given 28. BOC is 3x minus 2, which becomes 52. COD congruent to AOB is 28 also. AOD is 6x, which is 6 times 18, becomes 108. And I can check that if I add up 28, 28, and 52, that's also 108, so I get a check for that. And that completes section 1-4.